Hey guys, welcome back to Coding Simplified. So last time we took a look at how loops work in Python, and we compared the code that we write to a recipe, which the computer then uses to cook up our program. In this example, loops are like a step of the recipe that asks you to keep doing something over and over again. We use the example of adding cups of water to a bowl, and we repeat the step over and over until some condition becomes false, like when the bowl is full, for example. In our discussion, we also looked briefly at variables, but today we're going to take a much deeper dive into how variables work in Python. So, last time we said that variables are pieces of information that can change over the course of the program. So for example, we had a variable called cups that held a number that told us how many cups of water we had added to a bowl. In addition, we saw that a variable could also be a dictionary or a list, which are two structures that are built into Python, and they can store lots of data. These are sometimes called data structures in computer science. But variables can represent much more than that. And in fact, you can use them to store information about pretty much anything you want. And that's because under the hood, variables are really just pointers. You can actually imagine little signposts with arrows on them if you want, and they point to a certain chunk of the computer's memory. But since the computer stores everything in big blocks of zeros and ones, when we have different types of variables, it's really just a shorthand that's convenient for the programmer. It doesn't really make a difference to the computer. That said, it is good to know the common variable types that are built into Python. So let's take a look at these one by one. So there's 5 categories of variable types in Python. We have numbers, we have strings, we have lists, we have tuples, and we have dictionaries. So let's look at these one by one. So the first one we're going to take a look at is numbers. By the way, I should probably put these in comments so that they don't affect the code. So the first variable that we're going to talk about is a number, but there's actually different types of numbers that can be stored. The simplest one of these is called an int, which is short for integer. These can represent any whole number, which can be positive or negative. So some examples of integers would be what we saw before, cups equals 0. We can actually use the same name over and over if we want. All it'll do is update what's stored there. So we could say cups equals -1. Or we could even say cups equals 100. If you didn't believe me when I told you that this was an int, you can actually check it with Python. All you have to do is write type, and then parentheses, and put in whatever the name of your variable is. So if we said type of cups, and then we press play, it tells us it's an integer. So another type that comes up is a float. What's a float? Well, it stands for floating point, so we could have cups again. I was always confused by this when it was first explained to me, because no one told me that float just means that it's a decimal point. So if I said 1.0, that's a float. Or if I had 1,234.5, that's also a float. Why is it called a float? It's because you can imagine this decimal point floating back and forth. This kind of comes from scientific notation, where you have the raw number and then it tells you where the decimal point is supposed to be. Don't get too confused by this, though. All you really have to know is that when it says float, that it's going to be a decimal number. So then if we did type of cups again, it'll tell us that it's a float. We have a couple other types. One that's used for really long numbers called a long. It has a capital L that gets used after that. We're not going to look too deeply into that right now. There are also complex numbers where you can have an x part and then a y component that has a j that represents an imaginary number. Now, unless we're going to get into math, which we will eventually, but we're not going to get that deep into the mathy stuff right now, we're not really going to need to use this that much. Something that is going to come up a lot is the Boolean type. What's a Boolean? Well, it might sound confusing, but all it means is that it stores a true or a false value. This is kind of like the conditions that we saw earlier. So if I said is full, and then I could set it equal to false. Or I could say is full would be equal to true. And then let's try type of is full. There you go, it says bool. Now, as a side note, many older languages use a 1 and a 0 to represent true and false. But a cool feature in Python is that it can actually convert between these different standards if needed. And in reality, Python doesn't even really see this as its own type. It's more of a convenient shorthand. This seems to be kind of a theme in Python. So that's enough about numbers for now. Let's take a look at strings. So what is a string? Well, a string holds alphanumeric characters and pretty much anything you can type into the keyboard. These are normally used for names or for storing information that a user types in. So you could say something like, my name is Devon. When you write a string, you're going to put it in between these quotes. You can also use single quotes, but you have to make sure that they're consistent. So my name is Devon, and actually I could put type of my name, and it should be a string. There we go. str stands for string. Now something that's interesting, if we wanted to keep quotes in here, we can actually put quotes inside of these single quotes, and they'll actually show up if I print them out. So let's try printing them out. So if I say print my name, there we go, it includes the quotes. And if I put double quotes on the outside and put single quotes on the inside, any ideas what will happen? There you go, it prints the single quotes now. So these just have to match up. So the outermost ones tell you it's a string. Anything inside that is actually going to get printed out. So if you have double quotes on the outside, you can't have any more double quotes inside, but you can have single quotes. And the same is true the other way around. Strings can actually be added together. This is also called concatenation. And notice that there's actually no space when it gets printed out. So there's some things built in Python that you can do with strings, but I think we're going to have a separate video on what are called string methods. For now, let's move on to the next type, which is going to be the list type. So we've actually seen lists before in the last video. So if you remember, you could say something like my list equals, and then you actually just need square braces. And then you can actually put anything of any of these other types inside of the list, and they don't even have to all be the same type. So you could have a 0, you can have hello, you can have another list with 0 and 1 in it. And when I play this, it won't have any kind of errors. And actually, let's try type of my list. There you go, it's a list. Doesn't have to be the same type. This is different than a lot of other programming languages where everything has to be the same type of something. Now, to keep it consistent, it's generally good practice to try to keep things of the same type. So you can have 0, 1, 2, 3, 4, and they're all separated with commas. That doesn't change. Or you could have different words. Hello, my name is Devon. That's going to be a list. Now, if you remember last time, we talked about using a for loop as an iterator. So we could do something like for word in my list, and then we could print out that word. See what happens there. There you go. You got every word in the list printed out separately. So that's another example of loops that we saw last time. There's also a tuple type, which is normally used for math, but it doesn't have to be. And it's very similar to a list, except that you can't change the elements inside of here. Now, this isn't really something we've seen yet, because we're going to get into that with list methods. It turns out that you can remove things from a list, add things to a list, shuffle them around. But when you have a tuple, you can say my tuple equals, you're going to use regular parentheses, and you could say 0, 1, 2. But if I did type of my tuple, it's going to be a tuple. So we're going to see the difference between a list and a tuple a little bit later. Right now they might seem pretty similar, but a tuple can't be changed. And when it can't be changed, it's called being immutable. It's basically unstoppable. It's carved into stone. And like I said, we're going to look a little bit deeper at that later. So finally, we have the dictionary type. And we have already seen dictionaries before as well. So if we had my dictionary, you would use curly braces like this. Remember, the feature of a dictionary is you have some kind of key, like the word that you're looking up, and then a value, which is kind of like a definition of a word that you're looking up. But it could be any pair of anything. So you could have integers as the keys. All that matters is that there's a colon and then some kind of value. So maybe you could have a float there, then a comma, and then maybe you have a 2, and then you have some other kind of float. What it's doing is this colon attaches this key to whatever this value is. So when it looks up for the element with 1 in it, it's going to retrieve all this stuff. You can actually even have a list in here. So I could say 1 is attached to a list that says, hello, I'm Devon. And then you could have a separate list on another one that says something like, hello, I'm Paul, right? And then if we did type of my dictionary, any guesses what it's going to be? There you go, it's a dictionary type. Notice that all these names are abbreviated versions of what the full name is. Now, last week we also talked about using a for loop on a dictionary, so I could do something similar here. I could say for key in my dictionary, and then I could say my list equals, and then I'm going to find the list that's at that key. So I'd say my list equals my dictionary of whatever the key was. This is getting a little layered and confusing. I'm trying to show a little bit more complicated examples now. So basically, we're going to this dictionary. We're looking at every one of these pairs in the dictionary. We're starting with the first one. Its key is 1. So we're saying my list is whatever was in the dictionary with this first value. Then we're actually going to do a loop within a loop. So we're going to say for word in my list. So see how it's getting a little bit layered now? So for word in my list, and then we're going to print out every word in that list. We're going to print word, just like before. So now what it's going to do is it's going to print everything from this list. Then it's going to move on to this one, because this outer one's a loop too. We move on to the next key, which is going to be 2. We're going to look in the dictionary at that spot, pull the list out from that, which is going to be the second list. Then we're going to go to every word in that list. So this is our first time we've seen loops within loops. So basically, we're going to get everything from this list printed, and then right afterwards, everything from that list. Let's try that out. There we go. Hello, I'm Devon. Hello, I'm Paul. Just as a little example of how we can use some of these different things together. You can actually get pretty complex pretty fast when you start using lists and dictionaries. And there actually are dictionary methods too, which I will address in a later video as well. So the next thing I want to talk about is what you can actually name these things. And I've actually been doing it myself already, but there's 2 main standards for how you name things in programming languages. One of the popular ones is what's called camel case, where the first word is lowercase, there's no space, but any other words are capitalized. So my dictionary is an example of camel case. Or if I said my cool code, that would be an example of camel case. Now it's important that there's no spaces, and you also can't start with a number. And you can't have a variable that's already a name for something else. So if I say list, see how it becomes blue? That means it's already taken by the Python language. So if it turns blue, you can't use it. You can't use a number at the start, all kinds of things like that. Now there's another convention that gets used where instead of having spaces, you can just have your words like normal, but you can have underscores. So you could say, my cool code. Normally when you do this, you don't use capital letters. You actually can use capital letters if you want in Python, but this comes from programming languages where there is no difference between capital and lowercase letters. The general practice is to have lowercase words when you're using underscores, or if you're using camel case, you can say camel case, like that. So that's just a little bit about how to name these variables, because if you accidentally name it something wrong, your code might start bugging out for no apparent reason, although it'll probably tell you in some kind of error down here. So there's something deeper about types that I want to touch on too. In lots of other programming languages, programmers need to say which type of variable something is before assigning it. So you might even say something like int, my int, equals 0. And this tells the computer what type of variable this is going to be beforehand. This makes sure that when the code accesses the information pointed at by that variable, it always knows what to expect, and then it can make sure that the thing that's stored there matches what it expects. So if I'm telling the computer that this is an integer, and then later I try to say that it's a string, it's going to know that that's wrong and not let me do it. However, Python doesn't use this strong method of declaring what type a variable is, and instead it follows the idea of duck typing. So what is duck typing? Well, the idea is that if it looks like a duck and it acts like a duck, then it's probably a duck. That is, Python's smart enough to figure out what the type of each variable is based on its behavior. Now, although this is convenient for the programmer, sometimes it means that certain inconsistencies between what the code expects and what's actually written there can go unnoticed until it's too late. This is just something to keep in mind as you continue to develop your skills in programming. So one last tip that I want to share with you is that if you have more than one variable that you want to assign in a row, you can save a lot of space by using multiple assignment. So instead of doing something like frog1 equals 0, frog2 equals 2, and frog3 equals 3, which totally works, you could do something instead like this, where you get rid of all this, you put commas in between the frogs, making them into a kind of list, and you have an equal sign, and then you can assign them different values, and it can figure out which one's which. And it's the exact same code, but it's a little simpler. All that you have to remember is the first name is going to go with the first thing that's assigned, the second name is going to go with the second thing that's assigned, and so on. So something that happens pretty often is that we want to convert from one type to another type. So if I had something like an integer, and I said cups is 0, but then I had a string called myString, and I said that that was equal to cups plus some kind of string. Let's see what happens there. There we go. I get an error. So we have to convert this integer into a string so that these can be the same types. Now remember, as we saw before, when you add two strings together, it is legal. That's called concatenation. It's just going to be the two strings back to back. The problem is that we have an integer and a string, and they can't be added together. So what we have to do is write str, which stands for string, as we saw before, and then parentheses around cups. So what this does is it takes whatever's in the parentheses and turns it into whatever type's on the outside. This doesn't just work for strings, by the way. You can typecast between all kinds of different types as long as they're compatible and the code knows what to do with it. Worst case, you can try it out yourself and it gives you some kind of error. You can look at what the error says and try to figure out what you're doing wrong. But this should work for this example, so let's try it. Let's print myString. There we go. We have 0, which is converted into a string, concatenated to what was written here, which is string. And that's exactly what we wanted. Okay, so that about does it for the basics of variables. So there's a lot of subtle aspects of these variables that we haven't looked at yet, but we can address these as they come up in future videos. So if you haven't yet, make sure to like this video, subscribe, and hit the notification bell so you don't miss the next installment of Coding Simplified. I have some exciting new videos that are going to be coming up, and I don't want you to miss them. Thanks again, guys, and I'll see you next time.